So I just got a few questions that we'll work through today, probably pretty short, but also give some information about the final as well. And then I'll also leave some time. I'll leave some time open if you guys that have signed up have any specific questions or any questions, but we'll jump right into those last few problems that I want to work through. So one thing I want to mention, not files, assignments, is that in the grade book I updated some things. So before you would have kind of seen your grade for the online quizzes kind of coming from here. Actually, I didn't update it for your section yet. Well, what I will do, I'll update it after we're done here today. What I will kind of have displayed is, instead of like seeing your grade for the online quizzes here, I have dropped kind of your lowest three and have those scores, and I'll be updating those after class. Also, your Learn Smart, I dropped your lowest Learn Smart grade, and I'll kind of reflect your grade from that Learn Smart category in this separate category as well. I'll do the same thing for Excel and Connect once the due date is kind of passed. So after the end of the day today, I don't know if I'll get to it on Sunday, but for sure on Monday I will get kind of the updated, so you'll see what your Excel grade is with the lowest one dropped, and you'll see what your Connect grade is with the lowest one dropped. And then you can kind of play around, and you'll have your four kind of homework and online quiz grades, where you can play around with that, figure out your grade tool for what you need in the final to get different grades in the class, okay? But the last few questions we have to work through, I accidentally got the answer key here. So let me not get the answer key, but just get this additional linear regression file, right? So we'll download that here, pop it open, and we'll kind of work through the problems that we haven't worked through yet, which I believe we went up through 12 last class. So kind of starting with 13. So let's assume that I want to estimate the following regression, where I've got my Y, or my dependent variable, as football revenue. My X variable is male enrollment. So it's kind of the enrollment at the university, kind of specifically male, right? So maybe the idea I have here is that as there's more male students, demand for football is likely to be higher ticket sales, higher merchandise sales, etc. So what do I expect the sign and size of beta 1 to be? Well, this is kind of answering 14 at the same time, but let's just think about what the interpretation of this beta 1 coefficient would be. So the general interpretation is a 1 unit increase in the X variable predicts the Y variable will be higher, or if it's negative, lower by the coefficient value, okay? So here, a 1 unit increase would be one more male student enrolled at a university would predict football revenues would be whatever beta 1 ends up being, higher, or if it's negative, lower. I doubt it's going to be negative. So if we think about it, if I just have more students, it's likely I'm going to have more even just ticket sales, as well as merchandise sales and things like that. So we're likely expecting the sign to be positive, right? So here, my intuition probably tells me it's going to be that much higher, right? That's going to be a positive value. Now, what's the size of it? I won't ask you a question that's as ambiguous as this on the exam. If I'm thinking about the effect is one more student, I wouldn't think beta 1 is very high at all. Now, when I run the actual regression, I'm kind of surprised, right? Because having one more male student, now we could say, increases the predicted football revenues by, well, now I know what the value of beta 1 is, so 2,621, and the unit of my Y variable is dollars higher. So, I mean, this is a pretty sizable effect, but I mean, if we think about it in the grand scheme of things, 2,000 additional dollars, I mean, that's not a lot of additional revenue. And also, you'd be surprised at kind of the subsidy that comes from your tuition. So just having another student enrolled, the program is going to be earning some revenue from just the subsidies that it receives from the university, okay? So that's how we would interpret that male enrollment coefficient. How would I determine whether or not it's significant, right? So I've got this p-value here, which is 0. Okay, so another kind of, and so 14 really was the interpretation that we kind of already kind of cheated and did in 13. What if I had an additional question, which was, at what levels is the, well, here, I've actually got it here, so I'm just going to copy and paste it. So at what levels is this coefficient for beta 1 significant? Right? So when we think about what we're doing, we start out is we have this null hypothesis that that slope coefficient is equal to 0. I call it B here, call it beta, right? We could actually throw it in here. We start out assuming that beta 1 is equal to 0. Well, if we can reject this, what we're saying is we're rejecting that there's no relationship, or we found evidence that there is a significant relationship between male enrollment and football revenues. So we look at the p-value at 0. So can we reject this null? Well, we reject the null if the p-value is less than alpha. My alpha, right, we could do any level here. It's going to be less than 0.01, 0.05, and 0.1 because my p-value is so small. So I can actually say that this is significant at all 3 levels, the 1, the 5, and the 10% level. Okay. If I ask you, what's the test statistic for the intercept, right? If we go, I think I have it open here? Yeah, the formula sheet. We've got this test statistic equation down here for when we're looking at coefficients. All you do to get the test statistic, take that coefficient and divide it by the standard error. So here, even if I had put in something where you couldn't see that test statistic, all you do to get that test statistic is divide the coefficient by the standard error. Okay? So if we want this for the intercept, that test statistic is going to be what, negative 2,569,601 divided by 147,466. And in my calculator, I should be able to kind of reproduce this column, even if I wasn't able to see that column. Okay. Any questions over any of that from you guys? Okay with that? Okay. Another one I could ask is, what percent of the variation in football revenues is explained by male enrollment? So I literally just typed out the definition of the R squared, except not general, just in the context of my example, right? So the definition of the R squared is what percent of variation in the Y variable, which our Y variable is football revenue, is explained by the X variable. Our X variable was male enrollment. So I look at the R squared, it's 0.49. That's the proportion of the variation I'm explaining. So if I wanted the percent here, I'm explaining about 49% of the variation. Okay. So that's how we kind of interpret that R squared variable. If we then go down here and say, okay, look, I know that that's a pretty naive regression. That's a pretty naive regression there. So what if I included some additional control variables? So what's female enrollment, right? So males aren't the only ones that kind of matter when it comes to kind of buying tickets, merchandise. So I include female enrollment as well. So I'm capturing kind of total enrollment here. And then I also include, well, what's the level of revenue of their basketball program? So maybe this is just sports are popular at this school, or maybe there are complements such that if people attend basketball games, they attend football games as well. So I include those 2 additional control variables. I rerun my regression and I get this output, right? So what's the test statistic on male enrollment? Once again, all you do to find these test statistics, take that coefficient on the variable you're interested in, so 1,582, divide it by the standard error on that estimate, and you'll get that test statistic. You can do this for every single one of these variables, and reproduce all these test statistics. Okay? So that might be some good additional practice to kind of do on your own. What else? Oh, I know what I want to do. So include some additional questions here. So what if I wanted to interpret the coefficient for the estimate, interpret the coefficient for the intercept? So the way we interpret this intercept generally is if all X variables are equal to 0, the predicted value of our Y variable is the, I can't type, intercept coefficient. Okay, so for us that would be a school with 0 male and 0 female students enrolled, and men's basketball revenue of $0, we would expect their football revenues are negative $1,801,907. Now this seems like a weird interpretation, and a lot of the time, especially when we start including a lot of control variables, this intercept doesn't make a lot of sense. How can I have negative revenues? But the reason why is because if we think about what we're doing with the intercept, it's when all variables are equal to 0. So if we just think about this from a very simple kind of linear regression example where we only have one variable on that right-hand side, how could we end up with a negative intercept? That doesn't make a lot of sense when that x variable is equal to 0. Well, even if I just think about this as here's enrollment, here's my revenues, right? A negative intercept means that this y-intercept, right, is negative. Right? So this is like the negative 1,807,000 or whatever. Well, that's probably because the actual data that I see, so here's all my data points. If I'm trying to get a line of best fit, it's not, doesn't look great, but imagine that was the line of best fit of the data. It might have to start down here at a negative value. Now, do I actually observe universities that have 1, 2, 3, even 100 people enrolled that have a football program? No. And so the interpretation will be weird because we don't actually observe this in the data. But we still need that intercept in order to get our line to best fit that data, right? We can't start it up here because now if I'm trying to draw a line to best fit that data, it's not near as good of a fit, right? So that's why the interpretation is a little bit weird for the intercept sometimes, but we still always interpret it. If the x variables are equal to 0, that's the expected value or the predicted value for y. Okay, so that was a good one. So what if I wanted the effect of interpret the, oops, so we'll do 20. So what if I want to interpret the coefficient on basketball revenue? Well, once again, it's a 1 unit increase. So how is basketball revenue measured? We go back up and read about the variables. It's a $1 increase in basketball revenue predicts that football revenue, our y variable, would go up by whatever that coefficient is, which is 1.69. So $1.69, right? Because our y variable is also measured in dollars. So 1 unit increase in the x variable predicts that the y variable goes up, or if the coefficient is negative, down by whatever that coefficient of value is. That's always how we interpret it. Okay. What if I asked a question like, which of the included independent variables are significant at the 10% level? So we said when we say that something's significant, it's because we can reject the null that the relationship is 0. So here at the 10% level, my alpha is 0.1. So which of these variables have p-values less than 0.1? We go look at these p-values and say, well, for male enrollment, 5.1 times 10 to the negative 41st, essentially move that decimal point 41 places to the left. Well, that's a p-value of pretty much 0. So p-value of 0 is definitely going to be less than 0.1. For men's basketball revenue, it does have a p-value of 0, so it's definitely less than 0.1. So we would say male enrollment and basketball revenues are significant or have a significant relationship with our y variable of football revenue. If we look at female enrollment, right, that p-value is 0.23. We actually, that's not less than 0.1, so we fail to reject the null. So we would say that for female enrollment, the relationship is insignificant, right? Or we're not able to say that it is significant. Okay? So here we can only say that 2 of the variables are significant. What about, if I said, oh, actually, no, sorry, that is the next question. I'll have to add that one. So the next question, how much more of the variation am I explaining by including these two additional control variables, right? So how much more of the variation in football revenue am I explaining by including female enrollment and men's basketball revenue relative to when I didn't, right? Well, when I only included male enrollment, the R squared was 0.49, so I was explaining 49% of the variation. Now my R squared, after I've included these additional controls, I'm explaining 63% of the variation. So how much more am I explaining? Well, you would just take the new R squared and subtract the old R squared. So 0.14 or 14, we're explaining 14% more of the proportion of the variation or 14% more of the variation. Any questions on any of these that we've kind of worked through? For those of you who are still kind of on here. I mean, that really should cover any question I could ask you about linear regression. So we went through and we did interpretations of coefficients, interpretations of the intercept. We did test statistic, calculating these test statistics. Hopefully these are like really easy points. I mean, we're just taking the coefficient and dividing by the standard error. We talked about how we use the p-values to determine whether or not something is significant or we can reject the null. We thought about what R squared is telling us down here. Interpret intercept. Yeah, so this really is the only types of questions that I'll kind of be asking you, right? But I could ask you something, as I said, it's not completely true. I could ask you another question, right? So assume a university has 4,000 female students and 5,000 male students, and the basketball revenue they're earning is, I don't know, let's just keep it easy. We'll say $1 million. Right? So if that's the scenario, oops, what is the predicted football revenue for that school? Well, once we have the regression output, if we think about what we have here, right, let's go to our formula sheet. We can come up with predicted values for y by simply taking the intercept value we get from the regression output plus the first variable of if we have a value to plug in times its coefficient plus a second variable times its coefficient, et cetera, et cetera. Okay. So here we've basically got this equation. We know now beta 0, beta 1, beta 2, beta 3, and I just gave you values for this specific university or this kind of hypothetical university that we're trying to predict football revenue for. So I'd go through, take the male enrollment coefficient, so 1,582 times, well, how many male students does this school have? Times 5,000 plus the coefficient on female enrollment. Well, it's negative, so instead of plus, it's right, it's going to be a minus 131 times what was female enrollment at this school, 4,000. Plus the coefficient on men's basketball revenue, 1.69, times what was the hypothetical university's basketball revenue, 1 million, so 1, 2, 3. This should give me my predicted football revenue, with the exception of one thing I forgot. I still need to add in that intercept, right? So at the very beginning, we could have had, right, I'm going to add in that intercept, which because it's got a negative sign in front of it, right, we're actually going to be kind of subtracting. I forgot that negative sign. There you go. So here it's just a matter of entering this into my calculator and coming up with that predicted value for y. Okay, so that could be a question I ask. Another one I could ask is, what is the effect of 2 million, well, let's say of an additional $2 million in basketball revenues on predicted football revenues? Well, if I know the effect of $1 increases of basketball revenue, so the effect of $1 is 1.69, to get the effect of 2 million, I would simply multiply that by 2 million. And that would give me the predicted increase in football revenues from a $2 million increase in basketball revenues. Okay? I mean, that's really the only kinds of questions I could kind of ask, or I'm going to ask you on related to linear regression. Earlier this week, we went over kind of the earlier kind of hypothesis testing stuff. Oh, sorry, this is the wrong one. We went over on practice exam A, and we went over 2 population hypothesis testing examples. I also posted an additional video that I did. No, sorry, we did practice exam B. I posted an additional video of doing practice exam A problems. Okay, so that's up on the YouTube playlist. So those would be 2 good things to review. If we look at that formula sheet, here we've got our confidence interval equations. And that's going to be a good thing to identify prior to you take the exam. Here are your confidence interval equations for 3 different types of examples. Here's your test statistics for hypothesis testing for 3 different types of examples for 2 populations. And then here's our matched pair example, right? When we had this difference variable, kind of went back to almost treating it like a 1 population example. But to kind of keep these a little bit more straight as well, we've really got 4 different types of examples that we could do for 2 populations. So the first was, well, actually, let me do it here. We've got the difference between sample means, but we know somehow the population variances. We also said we had examples where we're looking at the difference between 2 sample proportions. And anytime we see proportions or we know the population variance, we said we get to use the standard normal or the z-tables. The other examples we had was when we were looking at the difference in sample means, but we only had sample variances. We then had matched pairs where we had that difference variable. Sorry, this is supposed to be a D. We had the sample variance for that difference variable. And the last one, when we really complete, we actually could think about, we were doing hypothesis testing for that coefficient value, and we had our standard error. So these were all 3 situations where we'd use that student t-distribution. Okay? Now, we didn't actually like look up p-values or anything for the coefficient here, so we don't really need to think about like how would I find a p-value using that student t, or critical values using that student t-distribution for the coefficients. But for these 2 examples, right, the matched pair and the difference in sample means when we only have sample variances, we're going to use that student t-distribution. Okay, so that might be how to kind of keep those straight. What else did I want to say here? That should be good. So you've got everything kind of on your formula sheet to determine test statistics. Hopefully we're a lot more comfortable looking at p-values, finding critical values, making rejection decisions now, because that'll be like a large portion of the exam as well. So are there any other, I'll talk a little bit about the exam. It'll probably take me 5 to 10 minutes. But if there's any specific questions just related to any problem, I want to give you guys who have kind of taken the time to sign on a chance to answer now. Oh, that's not what I wanted. I wanted to chat. No specific questions? Any one problem? Okay. So I want to talk a little bit about the exam. First and foremost, that formula sheet is under this final exam practice materials. Actually, I'll go to our section just to kind of, so you can see. So here's the files tab. First things that you could be using are the student T in that standard normal distribution table. So those files are right here. You can open those up prior to the exam. Here under final exam practice materials, you've got that final exam formula sheet either as a Word doc or a PDF. So those would be the 3 things that I would suggest having open before you even start the exam, okay? I'm not going to do a lockdown or anything, so you can have those open and view them. In addition to that, once you start the exam, actually, I think it's, if you look at it, it should be sitting there. You just won't be able to open it until literally just after midnight on Sunday, so Monday morning at 12:01. You see it's out of 103.5 points. It's actually only out of 100. There's just 103.5 points possible, right? So until everyone's taken it, your grade's going to be a little bit off because it's the way that Canvas works. I can't set it to be 100 yet. Once everyone has taken it, I'll then kind of create like this new exam score that shows your grade out of 100. Right? But your points will be the total number of points you get out of 100, so that'll be okay. It has 15 multiple choice questions, and then 2 short answer questions that I think the one has 5 components and the other one has like 6 components. So it's kind of like 11 additional questions. So there's, if you want to really call it, it's like 26 questions on the exam. The short answer, probably a little bit more because you have to show your work. So it's a little bit longer of an exam, but you've got 2 hours to take it. Once you start, anytime between kind of that Monday and Wednesday, once you start, you'll have 2 hours to kind of complete and submit the exam. You can upload a Word, an Excel, a scanned PDF, or a picture as kind of to however you want to do your work to show me what your work was for those 2 short answer questions. Show me as much as possible, because the more work that you show me, the easier it is for me to give some partial credit, right, if you do get the answers wrong. So the short answer portions are, well, let me think, just over, here, let me think, I can do this in my head real quick. So it was 15, let me see, 4.3 times 15. So they're going to be about 40% of the overall points, and then the multiple choice questions are about 60% of the total points. Okay. I would make sure you don't think that they're just one question though, so that you run out of time. Each short answer, like I said, is really, one of them is 5, part A through E, and the other one's part A through F. So they will take you some substantial time. So don't waste, save enough time to be able to complete those. But I think that should cover everything, all the information kind of for the final. It's going to be very similar to our other 2 exams we've done in the past. I also will be, even though it opens up Monday early, I will create after class today a Zoom link meeting for 2 o'clock, our usual class time, because we would have class on Monday, but I've worked through all of our additional review problems. So really what I'm going to do is on that Monday at 2, I'm going to have the Zoom on for an hour. And if you want to stop in and ask me any questions, you can do that. So kind of like last minute questions as you're studying, last minute questions, even if you have one about the exam, you can sign on during the hour and I'll be available. Okay. The other thing I'll mention, and it shows up once you open the final, but as same as the last exam, try to use Chrome or Firefox or even Internet Explorer. And Safari is the one really that has issues observing some of the equations if you use Safari. So don't find a computer you can take the exam on that has a web browser other than Safari, really. And I think that should cover it. I also wanted just another reminder, if you do get a chance to kind of do those evaluations, I'd greatly appreciate it. I know this is a weird semester, and even early on, you guys kind of hung with me through a few technical difficulties. Unfortunately, you were the kind of guinea pigs for doing this style of class. My sections next semester, I think, will thank you a little bit. I even kind of getting through this, I've learned some things I'll probably do a little bit different and tinker around with some things. So you guys are really, really good about that. And I guess that's, unless there's any questions, that should wrap it up for me. So if there's no questions here. Once again, I might see some of you Monday. I'll be available Monday at 2 if you want to ask some last minute questions. Other than that, feel free to reach out. I did a few Zoom meetings earlier today with people. Be more than willing to kind of meet with you. Not over the weekend, I won't be available, but Monday or Tuesday before you take the exam, even last minute questions on Wednesday, I'll be available to kind of meet and be constantly checking my email to make sure that hopefully we can get everyone to do as well as possible. Okay. All right. So if there's no questions, that covers it from my end. Hopefully, maybe I'll see some of you on Monday. Otherwise, enjoy your break and have a good break. All right.